Hi, hello, I'm Kiran Kumar from Nature of Physics. Students and friends, I'm doing many videos from the first year physics along with the second year physics, NEET, mains and advanced level videos. I'm doing and uploading the videos. Please watch that videos available in the playlist and do subscribe my channel Nature of Physics and Art. So today topic is thermal stress, that is based on the thermal force. For that, considering a metal bar of length is L. This metal bar is two ends connecting are fixed to the rigid support and heating. Due to the heat, this rod is observe the thermal energy. Due to the thermal agitation, here the rod get enlarged. That is, the size of the rod is increases due to the thermal force. So thermal agitation is takes place, exerted a force F on the fixed supports. See, two sides F force is acting because of heat energy observed by the rod and thermal agitation takes place in the rod. That's why it get enlarged. We know whenever heat is applied to the metal bar, then it will extend, but it is fixed with the two rigid support. That's why force exerted on the two rigid support, that force is called thermal force. So the elongation is taken as here delta L is the elongation. See, from the Young modules, Y which is equal to FL divided by delta L into A. From this equation, Y delta L into A divided by L which is equal to F. So F which is equal to YA delta L by L. See, delta L by L which is equal to alpha into delta T. So delta T is change in temperature. What is that? Change in temperature. So the basic formula, alpha is the coefficient of linear expansion, that is L2 minus L1 divided by L1 of T2 minus T2. T2 minus T1, T2 minus T1. See, from this equation we can write alpha is equal delta L divided by L into delta T. So I wrote delta L by L which is equal to alpha into delta T. We can write delta theta also. Okay, so we got this relation and replaced in the above formula. Okay, so thermal force F which is equal to YA delta L by L value is alpha into delta T, or we can write F which is equal to Y Young modules A area alpha into delta theta. Okay, delta theta is the change in temperature. We can write this is delta theta also, or delta theta, change in temperature. So here the thermal force per unit area, that is the thermal stress. So thermal stress, that is force per unit area, that is restoring force per unit area. So Y alpha into delta theta, See, from this formula only I wrote. And Young modules formula very well we know, that is longitudinal stress divided by longitudinal strain. So here the formula y, which is equal to F by A divided by alpha into delta theta, and from this equation we can write strain, which is equal to alpha into delta theta. That strain is thermal strain, and also we can write here strain energy, which is equal to 1 by 2 stress divided by y. This is stress square. Okay, stress formula we got, that is replacing in this equation. So strain energy indicated letter U. Okay, so U, which is equal to 1 by 2. So stress formula is what here? Thermal stress, y alpha into delta theta. So then y square alpha square delta theta square. Here y square and y is get cancelled, so the resultant equation is y a square delta theta whole square. We can write instead of delta theta delta t also. Just a minute. See here, first I am considering this is the metal bar fixed with the two rigid supports. See, the length of the rod is L and A is the area of cross section, uniform rod, and it is heated. That's why thermal agitation, due to thermal agitation, thermal force is exerted on both ends. That is, thermal force is taking as F. From the Young modules, so F by A delta L by L, that is thermal stress by thermal strain. That is, simple formula is longitudinal stress by longitudinal strain. We got here F value y into A into delta L by L, and delta L by L is what? Alpha into delta theta, or we can take delta T. Delta T is change in temperature, or we can take an as delta theta. Now alpha is the coefficient of linear expansion, a formula I gave you, and here thermal force, which is equal to just delta L divided by L value, is replaced as alpha into delta T. So delta L is what is that here? Elongation in the rod due to the thermal energy. See now here thermal stress, that is simply force per unit area only. Next, from the Young modules we got here thermal strain, which is equal to alpha into delta theta, and strain energy, that is U, is equal to 1 by 2 stress square divided by y. So that stress is what? Thermal stress y alpha into delta t. Here y square y is get cancelled. Finally we got strain energy or elastic energy 1 by 2 y into a square into delta theta whole square. So this is the explanation for the thermal force. Next, thermal stress and thermal strain and strain energy. Thank you. Just please do like and subscribe my channel and support me. I'm doing regular videos. Please follow.